All right, so now what we're doing is we're getting into how to solve a exponential function. So there's a couple rules that you need to know about or remember. So this is your basic rule. When your bases are the same, so remember when we're dealing with exponential functions, we're dealing with, we have a number for the base and the exponents are going to be our unknowns. So with this one, this is a general format. When I have the same base, when the base is the same, what that tells me is my exponents are going to be equal to each other. So to give you an example, if I had 3 squared and 3 to the x power, so again, my exponent is the unknown, my bases are the same, so all I have to do is pull my exponents down and they equal each other. So in this case, x equals 2. Well, it makes sense. If this is 3 squared, this side also has to be 3 squared because we have an equal, we have a balance. We have to make sure that they are equal. All right? Now, that same premise goes to if I had 3 to the 4x plus 1 is the same as 3 to the 7, 3 to the 7th power. Well, the minute I see that my bases are the same, all I have to do is deal with my exponents. If the bases are the same, the exponents have to be the same. So I bring my exponent down, and now I'm just going to solve my two-step equation. So x is going to equal 3 halves. So 6/4, I just divided both top and bottom by 2, and I get 3 halves. So what this says is if I plug 3 halves in here, I'm going to have it equal 7. So 4 times 3 halves plus 1, does that equal 7? That's what I'm trying to find out. So this is how you deal with fractions. I'm going to cross cancel. So 2 times 3 is 6. 6 plus 1 does give me 7, so I know that this is the correct answer. Okay, so bases are the same. You just set your exponents to equal each other. Let me give you another example. If I had 6 raised to the 3x minus x squared equals 36. Now, with this one, my bases aren't the same, but I can change it so that my bases are the same. So if I want my base to be 6, this 36 can be rewritten as 6 squared. So now, my bases are the same. As soon as my bases are the same, I can set my exponents to equal each other. Okay? So now I have a situation. I'm still trying to find out what x is. All right? I have a x squared. So I have negative x squared plus 3x. And I'm going to bring this 2 over as a minus 2. So remember, we want to set it to 0, and then we're going to factor it. All right? Now, you can use quadratic formula, or you can try to factor. So in this case, we can actually factor. I can factor out a negative 1, and I get x squared minus 3x plus 2. Okay? So now this negative 1 has been pulled out, and all that meant, all I did is it just changes the signs. This went from negative to positive. This went from positive to negative. This went from negative to positive. And now I can factor this. So what do I multiply to get 2 and add to get negative 3? Well, the only factors of 2 are 2 and 1. The only way for me to add them and get negative 3 is to make them both negative. So negative 2 plus a negative 3, Katie, is negative 3. Negative 2 plus negative 1 is negative 3. Negative 2 times negative 1 is a positive 2. Okay, so those are my factors. Set 2 sets of parentheses. I have x minus 2, x minus 1. And now I'm going to use my solving by factoring. So I'm going to do this up here. I'm going to set each factor to 0. And then I'm going to solve. So for this one, my x equals 2. I'm going to add 1 to both sides on this one, and my x equals 1. So again, because I have a quadratic, the x squared term, I'm going to have 2 answers. So x equals 2 and 1. All right? Now, if I'm not sure, what I can do is plug it back in here. And we can see is it going to equal 2? So I always want to plug it back in to make sure I don't have any what's called an extraneous answer. So if x equals 2, I'm going to plug it into here. I'll do it up here. So 3 times 2 minus 2 squared. So 6 minus 4 does equal 2. So 6 squared does give me 36. If x equals 1, I get 3 minus 1 does equal 2. So that tells me that both of those are correct answers. Okay? So again, bases need to be the same. As soon as the bases are the same, then you can set your exponents to equal each other and then solve for x. All right, so another part in this exponential function scenario is when you have a function with e to the x power. Okay, now on your calculators, you are going to have an e button. An e is what's called a natural number. Okay, it's a natural number. It is seen in many different nature type problems. Anything that has to do with growth or decay, that's where you're going to find the natural number. And this is actually a number. It's an irrational number. And it actually equals 2 point, I always got to make sure that I get the right number, 2.718288 718281828 and so on. All right? It's an irrational number because this never repeats itself. It looks like it does, but it really doesn't. If we kept going with the number, you would find that it doesn't repeat itself. So it's actually a number. It's exactly the same thing as pi. Pi is 3.14 1592654 and so on. Okay, so pi is also a irrational number. So when you see the number e, okay, it's a letter, but don't think of it as a letter. It's an actual number, okay, and it just is represented by the value e. All right, so you can see this is still an exponential function. I have a number raised to the x power. Okay, so e is a number raised to the x power. It's an exponential function. And so e is going to be used quite often when we get to the applications. So one example that I wanted to show you is when you're looking for, you have an equation and you're solving for e. So you have an equation. This is a number raised to the x value. One thing about any exponential function is it cannot equal 0. So if you noticed, when I did the graph and I put in 0 for my x value, right? So 0 right here, it equaled 1. When I put -1 in there, it would be 1 over e. When I put +1, it's just e. So what happens is we can never have an exponential function go to 0. It doesn't equal 0. So what's nice about that is we can set this and factor out the common factor. So in this term, if you notice, e to the x is in common. So I'm factoring out my greatest common factor. What's left in this term is x. What's left in this term is 10. I'm still setting them to 0, but because of this rule right here, my e to the x cannot equal 0, so that is a moot point. It's an extraneous answer. But when I set this factor to 0, I can actually solve and get x equals -10. All right, so when you see an equation like this, just look at it and factor out what's in common. Normally it'll be something e to the something power. And then whatever's left, you can set to 0 and solve, just as if it was a factoring problem. Okay? And then you'll have another example. It looks like this. So e raised to the 2x plus 1 minus e equals 0. Okay? So again, remember going back to that idea that you have the same base. I can move this over here, so I can add e to both sides. So I get e to the raised to the 2x plus 1 equals e, and I'm going to write that in there because it's raised to the first power. Well, now I have bases are the same, which tells me that my exponents have to be equal to each other. Okay, so now I have a two-step equation. I'm going to subtract 1 from both sides. I have 2x equals 0, so I'm going to divide both sides by 2. So my x equals 0. So 0 divided by anything is always 0. If I want to double check, 2 times 0 is 0. 0 plus 1 does equal 1. So I know that that is the correct answer. Okay, so it's just a way to be able to solve. Anytime you have a setup like this one, just move one side to the, or move one value or one term to the other side, and then you'll have the same base, and then you can set your exponents to equal each other. Okay, all right, so we're going to stop, and then we'll do an application.